And that being said, we go into the webinar side of things for this community meeting. And as we said at the beginning, the goal of this one is actually to explain and to dive a bit deeper on how you can set custom connectors into your own open metadata deployment. But before that, for those who are new or for those that have already been with us for a while, but maybe are not that aware on what are the foundations of open metadata, let's do a quick review on two super important topics that are actually the ones that enable us to work on these custom connectors. The first one is the open metadata standard, right? In the end here, we understand each other because we all try to speak and to speak in English, right? We have this common language. We have this way of sharing information with us. So this is actually the same that happens when we are talking about software systems. So in open metadata, we are not only releasing this metadata management platform, we are also building it and releasing this open metadata standard. The idea is that we have a way to define all of the assets that interact in a data platform, be databases, be tables, dashboards, be the actual physical service that is the one providing all of the tables. And here, for example, we are already answering questions such as, okay, what does it mean for an object to be a table? It needs to have a name. It needs to belong to a schema. It needs to have some columns. Then these columns can have a series of supported data types and so on and so forth. So we are putting not only the descriptions, but all of the validations in their types and all of their possible relationships from asset to asset. And actually, and what makes open metadata interesting here is that we are not just stopping at the asset itself, because we want to bring and to close the collaboration gap between the data side of things and the people side of things. So in the same way that we can define what a table is, we can also define what are those relationships with folks that are part of the data platform. So a table can be owned by a user. Then this user can be part of a team. It can interact in some discussions in the threads and so on and so forth. And all of this information lives together into the open metadata standard. Then, once we have this language, we are actually able to say, okay, now I'm in a good place to go into all of these different metadata sources and integrate them into open metadata. Because in the end, a relational database, it's just going to give me a partial view of the information. A data warehouse, it's going to give me another side of the story. The ETL, it's what links all of these movements together, but they might not be sharing the same definitions. They might not be sharing the same descriptions and the same connections and the same APIs and the same interactions. So if we try to just get all of this data in isolation, this is going to get really, really hard. So what we're trying to do with open metadata is to create this central piece that's going to lie in between all of these integrations in our sources of truth and all of these possible applications that we can make once we have this metadata properly defined with names and surnames and with a set of operations powered by the APIs that allow us to say, hey, now I can create a catalog, which is the one that we are shipping to allow you to collaborate, to allow you to discover. This is also what it's powering our data profiler and quality tool. This is also how we are defining these specific freshness tests that are part of the observability of open metadata, and so on and so forth. Once we have this integration, once we have these APIs, once we have this language, we just need to keep building on top of this based on our needs. Now, that being said, we have some source systems, we have open metadata in there integrating all of this information. I have the single place to go, discover, collaborate, see everything that's going on with my data platform. But in some cases, that's just half of the story. This works when we have some external systems that we already know how to connect and how to interact with. Maybe I have some tables in Snowflake, and these tables, I spice them up with some dbt transformations, and they at the same time generate some new tables that then I can visualize with Metabase, and all of this is orchestrated with Airflow. In the end, all of these tools here, all of these tools on the right-hand side are tools that are generally available in the industry. So those are tools that we as the open metadata community, we can come, integrate with the tool, define all of these connectivities, define this transformation process from what the metadata looks like in the source system and how I can translate that into the open metadata standard and send it to the server. That's awesome. But what happens if inside our organization we have some specific business needs that are only applicable within our business, within our team even? Those internal systems are still places where metadata is important, and it is important to be shared and is important to be seen in this holistic, more general view and together with the rest of our data platform. So what we are going to be looking at today is how we can close the gap between these internal systems and the other external ones that we already know how to give and how to bring inside open metadata. So how do we bring it? How do we close with this gap? How we create this communication with ad hoc solutions and open metadata? The idea is that we have different solutions, and not all of them are going to be giving us the same benefits, and not all of them are going to be working in the same use cases. So what we're going to do now is we're going to explore all of these different approaches, and in the end, we're going to deep dive a bit more into how you can create the custom connectors as one of these possible approaches. But if we try to look at them a bit together, we can see that on the left, we have API calls. We said that everything is centralized with the APIs. We have said that everything is focused and founded by this open metadata standard. So we can directly use these API calls to interact with the server. And for those of you that might not yet be aware of that, everything that you do in the open metadata UI, that's an API call. So absolutely everything can be automated with API calls directly in the server. What's the benefit here? We have all the flexibility in the world. As long as it's something that it's supported by the server, we can just do this API call and get on with it. What's the maybe not so good part out of that? That we really need to know what we're doing. We really need to know what's this language. We really need to know how we can exchange all of this information. And on the other side of things, we have the ingestion framework. This is the Python package that we have been developing in the community, that we have been developing as part of the Open Metadata project. That is the one that helps us connect to the sources, understand the origin of the metadata, then do the translation into the Open Metadata standard, and finally send all of this into the Open Metadata server. So what's interesting here is that we already have a lot of boilerplate. We have a lot of word trails. We have a lot of processes that are already based on all of this logic. So we don't need to do as much work. But this means that we need to be in a position where our needs align with the abstractions and with the processes that the ingestion framework brings. So let's go step by step and see these different examples and how would they look like. This is a sample call on how I can actually create a table with the API. I'm just running a put pointing to the Open Metadata server. As always, we are sending here the JWT token. For those of you that might not know that yet, this token, you can actually get it from the bots page. You can either use the token from the ingestion bot, or you can create your own bots with specific scoped permissions that then can maybe help you rely in a bit more secure way for different applications. And here, I'm just creating a super small table. It's only going to have a name. It's only going to have a column. And it's not going to have an owner. It's not going to have a table type. And I'm just passing on which database schema this table belongs to. This is fine. This is great. This is all games. But here the question is, how do I know that I need to pass the name? Or how do I know that the table type can be null? It's some information that if I just want to use the API raw, I will need to check either by validating the JSON schemas, either by going into the Swagger docs, but I don't really have any helpers here to help me understand, okay, maybe I'm just doing a typo, maybe I'm just passing a data type that it's not properly supported, and so on and so forth. So if we go into pros and cons, the pros will be, hey, there's close to no requirements as long as you have curl, or as long as you have any library that lets you interact via API calls, you can already start automating things in OpenMetadata. The con will be that you really need to know what you're doing. You can go into Swagger, we have a bunch of examples in there, but building all of these JSONs for big tables, for big pipelines, it can end up being a bit verbose, and we don't get some of the validations when we are actually playing with the code and deploying it. In the middle, in our graph at the beginning, we have the Python SDK and the Java SDK. I like Python a bit more, so here I'm just going to show you folks the example about Python, but it will be very, very similar if we go to the Java side. So here in this example, what we're seeing is how with this SDK we can create a connection to the OpenMetadata server. Again, we are just passing the port and the JWT token. And based on this connection, now I'm going to create this create table request object. And as we can see here, we are already talking about different things. I'm not just creating a JSON file. I'm creating an actual Python class. And this Python class is going to support some arguments. And these arguments are going to need specific types or are going to need to be fed from specific other classes. So in this case, I know that I need to pass the name, that I need to pass this database schema that looks like it's another object called entity reference. And here, when I'm passing the columns, I'm passing something of type column, and I'm passing a data type which is of type data type. What is interesting here is that all of this information, all of these validations can already happen on the Python side of things. I don't need to wait until I run the API call and the server cries. Python is just going to cry a bit before, and it's already going to help me with all of this development. And not only that, but if you also use the Python SDK, you are going to have some other goodies, some other helper methods that are going to make your life a tiny bit more easier. So for example, we are already shipping, and I'm just putting this example because we have had a couple of questions around that today. This metadata object also has some helpers to allow how to patch descriptions of a table, how to patch the descriptions of columns. So all of these little interactions, we are already coding all of this logic and shipping it as part of the Python SDK. But some question that many of you might have here is, okay, this is good, it's interesting. I can create some of these standard language objects into the Python side. How can I make sure that the objects and these definitions that I'm putting on the Python side are actually going to match everything that's going on in the server? That's a very good question. And the answer is because we are centralizing all of these definitions of the standard via JSON schema. And the good thing about the JSON schema, it's not only that it's super expressive. So it allows us to put the names, the types, the descriptions, constraints. It allows us to put a bunch of things, but it also has great tooling support. So from this single repository of JSON schemas, we can automatically generate the Java code that it's going to power up the server, the Python code that it's going to be the basis of the Python SDK, also the TypeScript code that is the one helping us with building all the UI, as well as how we are storing the data, the metadata in the database and the documentation. So if you are curious and you want to learn a bit more about which tools we are actually using to make these transformations, you have all of the links here. Many thanks to the communities and the folks that are actually powering up these projects, because those are super, super helpful. But going back to the JSON schema topic, this is how we are actually able to make sure that all of these different pieces of open metadata, all of these different parts of the architecture that are even developed in different languages are always staying up to date and able to talk to each other. Now, closing the JSON schema parentheses, what are the pros of creating a table with the Python SDK? What we were just saying, we have this standard, they have all of these validations in Python. PyCharm is going to cry, VS Code is going to cry if I'm just doing some mistakes here. So we get all of these validations, as well as what we were also saying before, all of these helper methods to make our lives a bit easier. So maybe I don't want to interact just raw with an API. We have all of these utilities on top that help us create all of these logic flow. And what's the con? That it's language specific. You don't want to use Python, or you don't have somewhere any Python environment or Java environment to run all of this logic, then maybe you are better off by using directly the API. But again, this depends on your use cases. This depends on the context of the solution that you are going to build using all of these APIs automations. And now that we have done a bit this API journey, this journey through the abstractions from the raw API to this Python SDK powered by this JSON schema, now we are finally landing into the ingestion framework. And here, I'd like to start by explaining a bit how we are actually organizing and defining the workflows that we run from OpenMetadata. And this is true from the ones that you deploy from the UI, or also from the little code snippets that we share for you to run on your own orchestrators, because in the end, they all use the same underlying classes. They all use the same workflow structure, that it's based in getting the source data, connecting to the source, extracting the metadata from them, and kind of trying to understand what's going on and doing this translation into the OpenMetadata standard. Then we optionally can have some processing of that data. That's actually what is going on in the profiler workflow. Here we connect and we extract the information about the tables. And here is where we are actually running all of the metrics. We are putting all of this extra logic from the data that we extracted before. And finally, we send the results of all of these computations into somewhere, which by default, this synced, this somewhere is the API. And again, this is what happens when we're talking about the metadata ingestion, when we're talking about lineage, DBT, profiler, data insights, Elasticsearch Reindex. All of this is what happens in all of these steps. Now, how this connects to creating this custom connector? The idea is that we don't need to focus, we don't need to really care about how this data gets into the server, because we already have this abstraction, we already have this logic flow on how the metadata gets extracted and how the metadata then reaches the OpenMetadata server. So the main benefit of just creating this custom connector is that we are only going to be working on the part of the source. We don't really care on how this information then gets flown internally, step after step, how the API qualities to send all of these metadata objects into OpenMetadata. We don't really care about that. We just need to focus on this first piece of here. How do we extract the information from my internal systems? And how do I do the transformation? How do I do this translation from the metadata from the source into the OpenMetadata standard? Other goodies that come from here, that this ingestion framework is actually what we have very well embedded into the OpenMetadata UI. So while if you use the API or directly the Python SDK or the Java SDK, you would need to find your own solution into hosting and running that code, be it a random script, be it a CI/CD process. We also wrote about that a couple of weeks back on how you can actually use the Python SDK to extract metadata from a custom ML model and send that to OpenMetadata. That would be a very good use case to use the Python SDK because we have a CI/CD pipeline. And you want that every time that you push an ML model to prod, you have the metadata updated. That's a different use case than when we are talking with the custom connector. Here, what we are bringing is this definition of the source, is this a skeleton on how you can connect to a specific source system in the company. And when this gets integrated into the UI, any OpenMetadata admin can create the ingestion pipelines, can schedule them directly from there. So you don't need to add any more whistles into the architecture. You just play and define how this extraction and translation of the metadata works, and OpenMetadata is going to be taking care of the rest. And this is basically the, I just got overexcited and I didn't change the slide. That's basically the discussion that we were just having, right? The pros, just focus on the logic, define what you need to define, forget about the rest. The cons, you don't have as much flexibility as if you were just playing with the API, because you need to make sure that your pieces fit with the definitions that we have in the OpenMetadata workflows. That being said, let's just start with the demo. Let's do some action and let's hope that there's no more demo effects aside from the internet breaking here. So what we're going to do now is we're just going to imagine specific use case when in our organization, we have a process that creates a CSV with some data. In this case, I didn't have much more imagination than creating a CSV that is defining the names, the columns, and the types for a series of tables. And what we're going to do, what we're going to play with this custom connector is that we're going to read the CSV, we're going to validate that the information in there is actually what we are expecting to get. What we were saying before, we're going to translate this source information into the OpenMetadata standard. And finally, we're just going to knock on the door on the next step on the workflow and just forget, because this is going to happen automatically. The process of, okay, now we have everything translated and how it reaches into the OpenMetadata server, the ingestion framework is going to take care for you. If you want to follow this along, either now with me or at your own pace, whenever you want, we have all of this code that I'm going to show you in this OpenMetadata demo repo. We not only have this, we have some demos on how to play with custom lineage files. I think I had an example with Hive, how you can also integrate with the Postgres foreign tables, how you can integrate with Redpanda. We have a bunch of demos and examples in there, so feel free to take a look and see if you can reuse some of these processes for specific needs that you have in either in your organization or in any other project that you might be playing with. So now I'm just going to jump here in the repo. I'm just going to zoom in a little bit more. And here what we're going to find are all of the necessary steps to make this running. But it's interesting. It's that if we just go here to the end, and actually I'm just going to start on the end. I'm just going to show you how everything looks like from OpenMetadata, and then we're just going to pull the thread a bit to understand what are the internals, so that when the time comes from you to create your own custom connectors, you already have some helpers, you already have some clues on where to start and what is it that you can customize here. So to start with the ingestion, I'm just coming into my own local OpenMetadata deployment. As you can see, I did a couple of tests before joining here, and I'm going to click in this custom database connector. I'm just going to give a name, click on next, and this is going to ask me what's the source Python class name. We're saying that this is custom. The ingestion framework does not know this implementation, so we need a way to actually pass the class that the workflow is going to need to load in order to run. In this case, we have this listed here in the README. So I'm just going to be copying this information. And we do not only need to pass this information, we can optionally add some other options, some other variables that for us might be important to control in each of the custom services. In this case, I am extracting data, from a CSV file. So what will I need to pass? Where does this CSV file live? So I have defined my custom connector to accept two connection options. One is going to be this source directory. So I'm just going to put this here and where the CSV really lives. And this other option here, which is just pour le fun of it, a business unit for us to give a name. I'm just going to say that the business unit is called sales. And before I run this, I want to show you how this CSV looks like. So this is the data that we're going to ingest, that we're going to translate, and that we're going to send into OpenMetadata. I'm going to expect to find a couple of tables named Table 1 and Table 2. Each of them have their own columns, and each of them have their own types. And note how here I just followed this convention, quote unquote, that the columns are going to be separated by semicolons, that I'm going to have a column named column names and another column named column types. All of these is just what makes sense for me in this example. It might be different for organization 1, it might be different for organization 2, it might be different from organization 3. But the idea is that with these custom connectors, we can make sure that the logic that makes sense in our context can be translated into this source structure that we need for the ingestion framework to run. So before diving a bit more deeper into the code, this locked me out. Sorry about that. Let me just add this information again here real quick. This was source directory and the sample CSV. Awesome. Going to save, and I'm going to create an ingestion because this is a custom connector. The ingestion framework knows how to create ingestions directly from the UI. Just going to leave all of the defaults, no DBT to configure here, and let it run every hour. Now, when I look at the service, this already started running, and it already finished. As everything, as we said, it's tied together. I can come here and I can check the logs, right? And I can come into my database view. You see this business unit parameter that I sent, it's going to be translated, in this case, in the database name. Why? Because I developed it in that way. It made sense for my use case. So I can just add this information the way that I need. Here, the schema is going to be default, and I'm just going to find my table 1 and table 2 with all their columns and all their types. The CSV did not have any more information, so there's no more information for me to parse and to translate. So that's it, but this is just a super tiny example on what we can eventually do by adding more and more and more information that is supported by the standard. So if we now just jump a bit here, I already had that open, into the code. In order for us to create this custom source, this custom connector, we just need to create a class that extends the source, right? So this is the class used internally by the ingestion framework that it's going to be the one connecting into my source system, doing the translation, and calling this next record to keep iterating on everything that needs to be fetched and sent into the next steps of the workflow. Now, if we take a look, this is my CSV connector implementation. In my next record, I'm doing different things. First, I'm creating the database service. Then I'm creating the database. based on my business unit name. Then I'm creating the schema, and finally, I'm sending that data. And all of this code here, you see, I'm creating a create table request. This is actually the same object that we were using here. So the ingestion framework completely powered by this Python SDK. So the same logic, the same learning curve that you're going to be able then to reuse in your CI/CD scripts is also going to help you to develop and build your own custom connectors here. Then the final question before we close this is, how can I make the OpenMetadata ingestion framework aware of this class? And the best way to actually do that is to extend any of our OpenMetadata ingestion images and pass your Python code in here. So in this case, I'm just passing the directory that contains all my files. I'm passing the setup to install the package. I'm passing the sample CSV for simplicity. And finally, I'm installing the information. So whenever I'm in the UI and I come into my service and I run this ingestion, this is running on this container in which I have already sent the code that is required for me to run this Python class. And that would be it for today on our side. That would be it for the highlights. That would be it for the demo. Thank you very, very much to everyone for coming. Thank you for your attention. If you have any questions, any comments, we have some time and this is for you. So please don't be shy.
Hi, this is Nidhi. I have a question.
Good.
Yeah, so this is regarding the tag propagation. Say I have a tag at a parent object. Can that be propagated like automatically to all the children in the hierarchy?
Suresh, you want to pick up this one?
No, so the one that Pere is talking about is connectors, right? For collecting metadata from the sources and ingesting that into OpenMetadata. In terms of tag propagation, now that our column lineage is getting more solid, we have had it for a couple of releases. We will start building tools which will automatically do that for you. You don't need to write a connector, right? So the example that Pere is giving is how to ingest the metadata from various sources. These ones are workflows that take the metadata that already exists in OpenMetadata and then make use of it to do certain things. In your case, tag exists on source table, automatically it gets propagated into the destination tables, destination columns. These are some things that we will build it ourselves. You would not need a separate connector. But, as Pere was giving an example, if you want to build it yourself, you could also do it, except that you'll be connecting to OpenMetadata and then you'll be writing back to OpenMetadata.
Okay, so this functionality is something that will come later. It doesn't exist today, right? That's what you're saying?
It doesn't exist today. There is a lot of automation that we have on our roadmap to build. Tag propagation, description propagation is one of them.
Okay. What about the ownership? I mean, if I have an ownership, say, for example, at a database level, can that be propagated or that will also come in later?
Yeah, so we have right now in 0.13.2, if you set up ownership at a database schema level, all the tables will inherit that ownership unless you change it, right? Manually.
That is perfect. Okay.
Yeah, the problem that we were seeing was people keep adding new tables to the database schema, right? And these new tables don't have owners. So now it inherits from its higher, from the hierarchy above. So database schema, owner is propagated to table, database ownership is propagated to database schema. And this is true for, many hierarchical objects that we have in our system.
Okay. Okay. This was one of our requests, and I think you guys have fulfilled that.
We added it because, because of your input.
Oh my God. Okay. Thank you so much. I appreciate it. Yeah, just a
Awesome.
shout out to OpenMetadata team. You guys have been awesome, in supporting me and my team. So I'm really very, very thankful. And we are actually using open metadata. Now it's official. So very, very, great thanks to Suresh and Harsha and Pere and all the people that who helped us with my lots and lots of questions that keep coming up, So super appreciated.
No, I think questions are very important for us. Also, if you have feature ideas, if something is confusing, the documentation is not clear, together as a community, with your feedback, we can continuously improve this. So feel free to just provide us any feedback. Don't hold it back.
I'm not holding back. I'm giving you more feedback.
No, this is for even rest of the communities. Please follow Nidhi's footsteps. Provide us feedback, any ideas you have.
There's one thing from my side. Hi, this is Leila from Move. And firstly, I would really like to thank the team, Suresh, Harsha, and Ayush, and Teddy, who are just being very supportive and constantly replying me for all my queries.
Thank you again, everyone, for joining. It was super awesome to see you folks. So any questions that you have, just feel free to reach out in Slack. Any ideas, open a fear to request. If you are brave enough, open a PR. We love seeing those. So please don't keep anything to yourselves. We're here to help, and enjoy the rest of your day. Thank you, everyone.